Hey YouTube, Soulkill here, and this is a common fidget toy that one might be able to acquire at something like a fair or carnival. But the unique thing about something like this is that it can expand and contract. And although this may seem just relatively trivial at first, it actually can be used to answer a very significant question about one of the underlying principles of our universe, which I'll be showing when I place this here on the floor in just a second. If I place it on the floor here, and then try to spin it, you'll notice something interesting about how it spins. So if it's fully extended out like this, its mass is all spread out, it will spin like this. But did you notice that at the end, it speeds up profoundly as it shrinks and the mass gets closer together? But why is this? It occurs because of angular momentum, an underlying principle of our universe, and a very significant part of angular momentum is that it is always preserved no matter what. Angular momentum isn't just how quickly something's spinning, it's that plus the inertia of the object. The inertia you can almost think of as just how much energy is required to move something or to deviate something from its current trajectory. Now, the equation for the angular momentum of an object is relatively simple. The first part of it is just the rotation, the actual physical speed at which it is spinning, and then that multiplied by the inertia. But the inertia is a bit more complicated than just velocity because it is found using the mass and the radius. The mass, of course, won't change when it's like this and like that, but one thing does change, the radius, because you're doing the mass times the radius squared to get the inertia. And when you shrink it, the radius is of course going to decrease. What this means is that the inertia is going to shrink because of course you're squaring a smaller number and then multiplying the mass by smaller said number. So you're going to get a smaller number for the inertia, but the overall angular momentum has to be the same number. It has to be preserved in a closed system where no outside factors can influence it. The only way for this to happen is for the velocity at which it is rotating to increase, though, and this applies to any object that is spinning. In order to keep it in balance, the object will spin quicker.